Hi everyone. In today's video, we are going to continue generating our intervals in our DateTime table. However, in this second part, we are going to do it inside Power BI instead, which sees us using DAX formulas instead of the Power Query M language formula. DAX formula is faster and more efficient as compared to Power Query's M language. That's why we'll be doing it in Power BI. You will notice when the data sets are large, DAX formulas will generate the results that you want faster. Now, before we proceed with the video, keep in mind that you can access the YouTube description for timestamps to seek over to the sections that you would like to see or review, and you can also refer to the pinned comments for the formulas that we'll be writing today. At least most of the formulas we'll be writing today. Now, let us have a look at our table view. In our table view, here I have similar tables as the one that we have generated in the previous video using Power Query. However, a few things are missing here and a few things are added back in. Let's talk about what's missing. First off, although we have start time formatted, we do not have end time formatted. And so we also do not have the duration minute column, which sees the end time formatted minus by the start time formatted. That's for what's missing. As for what's added back in is the start time and the end time column. The start time column is the precursor from which we develop or create our start time formatted column. I will explain as to why we decided to bring back the start time column later in the video. Now, let's jump back to our Power Query first. In my Power Query, I still see myself using index column as well as the list.generate formula here, which is something unique to Power Query. But I have reserved generating the end time formatted and the duration by minute in Power BI. In so doing, I can save at least two processes in terms of the time taken and the resources taken to generate their result. Let's talk about the first thing we gotta generate, which is our end time formatted. In Power Query, we will make use of the index in the index column and continue to bring all of the start time one row up. We can recreate the same result inside Power BI too. First of all, let me sort this column from 0, 1, 2, 3, 4, 5, 6, 7. And then we are going to create a new column by clicking over at my column tools, new column. Your column tools will appear if you have any column selected, like so. If you do not have any of your columns selected, but instead a table like this, then you would only expect to see table tools. In any case, you will always have new column to choose from. Okay, so for the new column, we are going to call it end time formatted. I'm using Ctrl plus to increase the size of my formula bars font. End time formatted, which would be the name of my new column. In my end time formatted, I'm going to make use of the calculate formula, which sees me taking one expression and one filter to create my index column. This expression is simply going to be my max start time formatted. Okay, for the filter part, which is the place that we'll be using to recreate the index column effect, we are going to first call the name of our table, which in this case is time, as shown here. And after writing time, I'm going to write the filter expression now, which will see the index column taking on the value of index plus 1. This would mean that for the rows with 0 as the index, this filter would filter to the row with 1 as its index. However, if I press on enter now, my data would result in blanks. That's because for my index plus 1 here, I cannot write it within my filter formula. Instead, I have to declare it as a variable first to be used in my formula later. So I'm going to call my variable next index equals to index plus 1. And then I'm going to call my next index. Here, I'm going to put a return first. So return will return the result of whatever formula that comes after. Now let's press on enter. And I see here now that all of my start time formatted is moved up 1 row to the row above. So this is 10:55:33, up 1 row. Let's see this 12 o'clock, also up 1 row. And then let's see this 4 o'clock, also up 1 row. However, I'd like to point out that if we scroll all the way to the end, I'm seeing 1 row that's returning a blank. In Power Query, it will return an error instead, which we can resolve using a try otherwise statement. If you would like to know how to handle errors inside Power Query, please visit the part 1 of this video. In Power BI, however, it will return to us a blank cell rather than an error cell. Usually in Power BI, we would handle error using if error. But since we are not seeing any errors in the return cell, we have to do things a little bit different. I'm going to first declare a new variable called now. Local now. This local now would see me calling the current time of my system or my device. Okay, and then I'm going to put an if function here that says if my index equals to max index, it's always going to be my last row that sees a blank cell return as a result. That would mean that the row with the highest number of index in my table would see a blank cell return. In establishing a logical test this way, I can identify the cell with the highest index number or the last row. If it is indeed max index, then I will ask it to return the local now, which is the variable I just declared. If not, then please return for me the formula I have previously written, which is my calculate formula. But having my formula like this seems a bit cluttered. So instead, I would prefer to have a new variable here. Let's call it the end time. Okay, and bring the whole calculate formula over. Perhaps it's better if I bring it down like so. And then here, I'm just going to ask it to return the end time variable, which is just declared over here. Let's press on enter and collapse my formula bar. It seems like it's telling me that expression that yields variant data type cannot be used to define calculated columns. Variant data type refers to this column cannot have a date time data and a text data at the same time. It can only have either one. By default, it's being set to text. We should be able to resolve the error by setting it to a date time. It is not resolved still. It's likely because other columns inside a reference inside this formula sees a text data. Let's have a look at our start time formatted and we see that it is also a text data. Let's switch it over to date time. Okay, now that my start time formatted is set to date time and my end time formatted is also set to date time, my columns is no longer returning error. Let's have a look at the very last cell and see if it is returning my system current time, which it is at 9:07. Okay, I have successfully generated my end time formatted column. Now, I have to take my end time formatted, minus it by my start time formatted, and find specifically the total minute that results from the subtraction. Let's add a new column to do that. In my new column, I'm going to call it duration. For the duration minute, let's first take a very simple formula, end time formatted, minus by the start time formatted, and see what returns as the result. Oops. It is currently returning to me a date time format data. That's because both of the columns that was referenced in the formula has date time as its format. So Power BI thinks that the result of this duration minute should also take on date time. We don't want that. So instead, I'm going to switch over to a decimal number data type over here. Maybe I should also mention that it is under column tools, which you will access by default whenever you have a column highlighted. Okay, now it is returning to me 0. A very long this decimal number. I'm going to reduce it over here to 2 decimal place. Okay, now let's take 0.04. Why is it returning to me 0.04? See over here that the duration in between these two dates is only 1 hour and 32 seconds. Sorry, 59 minutes and 32 seconds. We'll see that it is 39 minutes and 32 seconds when we times it by 24 and then times it by 60. It will become 57.6 minutes. The way that we are going to yield a minute result is by multiplying the result of this column with that of 24 and then 60. That's because this number that's being returned is actually day. It is returning to us the number of days as the subtraction unit. Okay, right. Let's take this. Let's declare this as, it's okay. We can just bracket it and then multiply it by 24 and then multiply it by 60. 24 because there's 24 hours in a day, 60 because there's 60 minutes in each hour. In so doing, we will get a significantly different number. Here, I have 1.18 minutes. I know that the difference between the start time and the end time formatted here is at least 1 minute. Let's see how many seconds is in 0.18. There's 10 seconds, about 11 seconds there, and 22 plus by 11 would yield 33 seconds. Okay, now we have obtained the duration by minute for our data. At this point of the video, the data is ready for us to populate it inside a visual. Let's start with a table first. In my table, I'm going to call my start time formatted, followed by my end time formatted, and then followed by my duration by minute. However, I do not want my start time and my end time to display it in date hierarchy format. To change this, I can come over to this drop down under each of the date hierarchy and choose instead start time formatted, which would then override my date hierarchy. Let's do the same for our end time formatted. I'm going to increase the font size by going to Format Visual and then opening the Values drop-down. Let's have the font size to 20 instead. And now I see that the same table that I was seeing in Table View is also being seen in my Report View. Now, notice here that I have a bunch of 60 minutes. That's because one of our data sees crossing day. Let's jump back to our table view to understand what we mean. It might be hard for us to see in the table view, so let's go into our Power Query instead and jump back to the the change type step. Here we see that for the first 3 rows, it is the 21st of September. However, beginning from the 4th row, it is the 22nd of September. The 3rd and the 4th row sees a difference of about 8 hours. Nearly 9 hours, I think. Yeah, nearly 9 hours. So when the hour interval is generated, let's jump back to our table view here. So 1, 2, 3 row, and then beginning from the 4th row, it is generating for us 12 o'clock, 1 o'clock, 2 o'clock, 3 o'clock, 7 o'clock, 8 o'clock, 9 o'clock, so on and so forth. So 19 hours, my apologies, 19 hours all the way until 7:55 over here. And then 7:55 onward is a different data point. So 7:55 sees us moving to 8:30 within the same day. Since we have the hour interval, that's why it is returning to us 60 minutes for every interval. Let's suppose I do not want to see these 60 minutes. I would instead prefer just to be able to see my data like this. So my 11:32 would go up 1 row, my 7:55 would also go up 1 row. We can do that, and that's precisely the reason why I have preserved the start time and the end time over here. Notice for our 22nd of September that sees a bunch of hours interval, all of their start time and end time are the same, 11 o'clock on the 21st of September until 22nd of September, 7:55 p.m. Because they are the same, I can then cut out my start time and bring start time formatted and end time formatted, and instead bring in start time as well as my end time. Again, I'm going to shift it from date hierarchy to start time. Now, instead of having a bunch of rows for my third result here, which is 11 o'clock p.m. on the 21st until 22nd September, 7:55 p.m., instead of a bunch of rows, it's just one row, 1,255 minutes. Here we see an even more drastic example of the 22nd to 25th September, which sees about 4,320 minutes. 4,320 minutes when we divide it by 60 and then 24, would see about 3 days difference, which in this case, it is a 3 days difference from the 22nd to the 25th. Okay, so that's the reason why we preserved the start time and the end time column, or their original start time and end time column. In having that column, in having a start time and a start time formatted, as well as an end time and an end time formatted, not only are we able to create a table like this, we can also create a bar chart with start time as my y-axis, x-axis, and then my duration minute as my y-axis. I should bring in start time format. And then I will bring in a slicer to put in the start time formatted, have it as a date hierarchy, and then switching it over to date by cancelling out everything else. Now, I can switch over to the 21st of September. Some duration start time formatted. I would prefer for it to just be start time formatted. Now I can see that at each hour interval, it is running differing amount of minutes. So let's say here, beginning from 11:32 p.m., it ran for 59 minutes until the 12 a.m. of the 22nd September. Let's see, so the 21st, right? Okay, so the 21st would see at 10:54 in the morning, 10:54 at night, 10:55 at night, and 11 o'clock. So here I will have differing 10:55, I believe here. Yep, 10:54, 1.18 minute, 10:55, 4.45 minute, and here would be my 11 p.m., 0.53 minute. The reason why it's 0.53 minute is because this is actually a crossing hour. So I calculated from 10:55 to 11, and then 11 to 11:32 seconds. So now this is giving us an hour interval. Let's have a look at maybe the 22nd September and see what happens. So for the 22nd September, because initially starting from 12 a.m. it's already running, so it ran for the same 60 minutes for many hours, and then only start trickling off at about 7 o'clock, which sees a new entry in the chain running. Afterwards, because it starting from 8:30 p.m., it continues to run until the 25th, so every hour also have a data. Okay, now it seems like my slicer is not very user friendly. Since my data only have 21st until 25th of September, I do not need any other dates that is irrelevant to us. We can choose to have a different field in our slicer. Let's see how we can do that. I'm going to now add a new column in my table and extract only the date for my start time. I will call it start date, and for my start date, it will be my start time formatted column and then dot date. This drop down is automatic for any column that you have called with the date time or the date format as its data type. Okay, dot date, and then I'm just going to press on OK. Now we see that for the first example, where it's 21st of September, it is returning for me 21st of September, 12 a.m. Remember, when we have a column that we reference in the formula that's date time, and that's all of the columns that we reference. Or maybe let's put it another way, if all of the columns or most of the columns in your formula that is referenced is using datetime as its data type, then the return result will likely be datetime. We'll have to change this to date for it to make more sense like so. Now, if I choose to have my start date column as my slicer instead. I no longer see the first, the second, or any dates that's irrelevant in my table. I only have the dates that is showing in my table, or at least existing in my table. There are certain dates that's not showing, specifically the 23rd and the 24th of September, because the machine continued to run in between the 22nd to the 25th. If I have my 23rd data selected, I'm just going to see a table like this, which often is unnecessary since by looking at this row, I would already know my machine is running the whole day. So I do not need to see that table that has 60 minutes for every hour. So let's find a way to remove 23rd and 24th September, or any dates that's not directly appearing on my table. We have to create a new column for this, and I'm going to use indicator, slicer indicator, as the name of the column. Indicator implies that this column is used to decide whether or not a certain date should be included in our slicer. For us to be able to write the slicer indicator column correctly, we have to first identify patterns in our data. Let's talk pattern. Scrolling all the way down to, let's say, the 25th, which would be over here, I believe. Yeah, over here. So starting from here, the second, sorry, give me a moment, over here. So this is the last row that is 7:55 to 8:30. Every row else is 8:30, 8:30, 8:30, 8:30, so on and so forth, which sees the addition of 1 hour, 1 hour, 1 hour as the interval. This is 25th, this is 22nd. Now, if it is within the same day as the start date, it will always be 22nd. If it is within the same date as the end date, the start time formatted will always have the 25th of September, which is the same as the end time. The 23rd and the 24th, let's see the 24th here, they are neither the same as the start time nor the end time. The same applies to the 23rd of September. We do not see this 23rd of September date in the end time or the start time. So that's the pattern we are going to use. I'm going to write two logical tests here, and again declare two variables. Afterwards, a return statement. In my first variable, I'm going to call it as complete as possible in the name, same as start time. Oops. Date same as start time, which would see me asking the question for the start time formatted. Dot date, is it the same? Sorry, is it the same as my start time date? The next one is asking about the end time. So date same as end time. Here, end time here. Now, this end time dot date is returning to us an error. We are going to fix that later, but keep in mind that's because end time is still currently in text data type rather than DateTime data type. Now, the evaluation would be include. We are going to write an AND statement here, but for AND statement, you got to keep in mind that in Power BI, Unlike Excel, we can only write two logical tests in the AND function in Power BI. Whereas in Excel, we can have a lot more logical tests. In Power BI, we can only write two logical tests inside the AND statement. To write more, we got to make use of the double ampersand symbol. There's only two logical tests here, but I'm taking the opportunity to showcase to you what do you need in order to be able to write multiple condition AND statement, or at least more than two condition AND statement. Okay, if date same as start time, then date same as end time. Now, this statement doesn't really make sense because if my date is the same as start time and my date is the same as end time, then I'm just going to have a 0-minute duration, because that would mean that both my start time and my end time sees the same value. I need to ask my question a little bit different. This is a not equal to statement. So if my start time formatted does not equal to my start time date, and my start time formatted also does not equal to my end time date. Oops, sorry. Okay, if this is the case, right, then if include means if include just means that if this logical test returns true. If this logical test returns true, then please exclude it. Not, then please include it or return the text included. If I press on enter, it will first return an error for me. That's because my end time, if I click on it now, is still in the text format. I'm going to switch it over to DateTime. And when I do that, notice that my slicer indicator is now immediately returning for me text. Now, my explanation for the slicer indicator may not be very clear, so let's have a look at instances where it's returning to us exclude. Okay, it's returning to us exclude because my start time is the 22nd, my end time is the 25th, whereas my start time formatted is the 23rd. Remember the two logical question or logical test is asking. Is the start time formatted date equals to the start time date? Let's fix the first one. So my start time formatted date, which is the 23rd, is not equal to my start time, 22nd September. So the first logical test would return false. For the second logical test, which is start time formatted, is it not equal to end time dot date? So my start time formatted, which is the 23rd of September, is not equal to the 25th of September in my end time. So this statement is also returning true. Okay, I think I spoke the wrong statement just now. This logical test is returning true. This logical test is also returning true, implying that the dates, the start time date in this specific rule right now is in between the start time and the end time, which is the date that we want to exclude. So this third variable is asking the question, are both of these true at the same time? If both of these are true at the same time, return true, which is the include statement here. If it is true, then let's exclude it. If it is false, let's include it. Now, all of our slicer indicator that has the exclude as the result are from the 22nd to the 25th. All the way until the end, it is still 22nd. Now, since we have this slicer indicator, notice here we want to let's remind ourselves again, we want to remove 23rd and the 24th. I'm going to bring in my slicer indicator now to the filter pane of this slicer visual. Afterwards, I'm going to click on include only. When I do that, my 23rd and my 24th September is missing because they do not directly appear on my table. They are the dates that are in between of the start time and the end time. With that, every time I click on one of my slicer, my bottom tables will always see a little bit of variation. So for the 22nd September, sees a little variation here, and then for the 25th of September, it sees a little variation. Okay, let's do a very quick recap as to what we learned today. Taking off from the very beginning of the video, we wanted to import all of the things that we did in Power Query into Power BI, which sees us using DAX formulas that is faster and more efficient in handling large data set. We initially only have status, start time, end time, and start time formatted, as well as the index column for our data view or the time table. We first make use of a calculate formula alongside with index formula to generate an end time formatted column, which sees us bringing the start time formatted one row above. Not only that, we learn how to handle any sort of error inside the end time formatted. However, this is not exactly error handling. In Power Query, it is error handling because the very last row in my table, let me clear off filters here. The very last row in my table in Power Query will return error since there's no more later rows for it to move any values up. But in Power BI, it returns a blank cell instead. So we cannot use an if error statement. Instead, we need to use a max index. Since my last row would see me having the highest number of index possible in my table. And only my last row will see a blank cell. At least that's how my data structure is set up. So we learned two things here, using calculate to move the data from one column, one row up, and then using max index to handle the error or the blank cell that occurred. Next, we learn how to calculate the duration minute by minusing two columns that are both date time data. Now, it's very important for both of them to be date time data because a text data cannot minus with another end time formatted. It just cannot perform any any mathematical operation. And then we multiply by 24 because there's 24 hours in a day, and then multiply by 60 because there's 60 minutes in a day. That's because this line returns to us the duration in days unit. Afterwards, we use a straightforward start time formatted .date formula to extract the date from the start time or the daytime column here. The date time column here. We only wanted the date, not the time. Remember, it's very important for you to switch the data type to date because by default, since start time formatted as the input in the formula as date time data type, the start date column will by default return to us a date time data type. The reason why we wanted to have the start date is so that we can simplify our slicer here. So let me cut out the start date first and let's understand better what we mean. Date hierarchy. Then, so if I have it like this, it's giving me a bunch of date that is irrelevant inside my data. That's why we brought in the start date instead, which would only give us all the dates that appears in my table. But previously, it was also giving us 23rd and the 24th, which does not directly appear in my data because they occur in between two in between a start time and an end time. That is why we created our very last column, slicer indicator, to exclude those dates that's in between my start time and end time. I run two logical tests and then ask if both of those logical tests are true at the same time. If it is, then let's exclude it. If it's not, then let's include that date as a slicer. So if all of this Sunday, September 24th are all excluded, then it will exclude all of them. Here it says include for all Mondays, September 25th. If you only include distinct value, means one of the many same values. For this to take into effect, we have to move our slicer indicator to our filter pane as we have my slicer visual selected, and then tick only my include selection. With that, we would be able to achieve a more relevant slicer. That's all for the video. Thank you. Bye bye.